Today we're going to talk about nested data. And we're going to talk about why it's important to think about nested data and why it's important to have special methods to deal with nested data. One of the classic examples of nested data is when we think about students who attend different schools. Now in this case, students would be considered the little units or the level 1 units, and the schools in which they are nested would be the big units or level 2 units. The reason this is important to think about is because we expect that in nested data structures, the little units, in this case the students, will often be more similar to each other than they will be to little units that are nested within a different big unit. In this case, students nested within a different school. So here we see the students on the right are a little bit more similar to one another than they are to the students on the left, and vice versa. Another example of nested data would involve individuals. In this case, we have two individuals and we record their mood. Then we record it again a week later, and then we record it again a week later. In this case, the big units are people, they're these individuals, and the little units are these weekly recordings. And again, we expect that the weekly recordings for one person are going to be more similar to each other than the weekly recordings for a different person. Finally, a third example might be households or homes nested within states. Here on the left, we see New York. In New York City, we have a lot of houses that are connected and close together, and it's very densely packed, but we have some homes that are in other parts of the state that are larger and more spread out. Whereas in Texas, we have a completely different style of home in some cases, although we do have some larger homes that are similar to the home from outside the city in New York. But either way, the homes in Texas tend to be different from the homes in New York. Let's return to our example of students nested in within schools to talk about variables at different levels of data. We'll start with a variable that is specific to the little units or the level 1 units, in this case the students. And we're going to talk about household income. Of course, each of these students comes from a different household, which has a different income level. So household income varies across the students. Now, that also means that the average household income varies between the big units or the schools. So here we see the average household income at each school is different. So a variable that is specific to level 1 units will also vary at the average level among level 2 units. Now let's think about the reverse. Let's consider an example of intervention study, where one school is assigned to treatment and another school is assigned to control. In this case, this variable only varies at the level 2 units. At the level 1 units, there is no variability. All students within the treatment school receive the treatment. All students within the control school receive the control. So the only variability that's of interest here, and the only variability that once we account for the variability specific to the level 2 units, there is no additional variability specific to the level 1 units. Now we're going to talk about this idea of random effects. And this can be a bit confusing, in part because it can have different implications depending on the field of study. So we're going to start with an example from psychology, which is what we will most often be dealing with. In this case, we have two individuals, Jenny and Johnny. Jenny and Johnny both enroll in an intervention study in which their daily mood is recorded over a period of time. Now, the purpose of this study isn't to tell us about how the intervention specifically affects Jenny and Johnny. What we really want to know is how the intervention would affect a random person. Johnny and Jenny are randomly sampled from a population, and this is why we call this a random effect. There is variability that's specific to Jenny and Johnny that we have to account for because their daily mood readings are going to be more similar from day to day than to each other. But again, we're not interested in that correlation. We just need to account for it so we can make predictions about a random person who receives the intervention study. And when we're doing this, we can of course record other variables that are specific to Jenny and Johnny. In this case, these are the level 2 units, the big units. We can look at their big 5 personality traits. We can look at their family history. We can look at their cognitive ability, so on and so forth. And we can look at variables that are associated with the level 1 units, in this case the daily readings. This might be the weather on a given day of the week, or stressful life events that occur on a specific day. But again, the purpose here is that we're interested in the effect of the intervention study. We're also somewhat interested in the effects of these other variables, these variables specific to the individuals, and these variables specific to the daily recordings, but we're not actually interested in the residual individual variability that's associated with Jenny and Johnny that we haven't measured. We have to accept that there is variability that's specific to Jenny and Johnny to make our methods work, but it's not of substantial interest in predicting what's going to happen when our intervention is given to a future person. We might still record these other factors with this other person, but we're not interested anymore in the residual variability that was specific to Jenny and Johnny beyond these factors. Now let's consider a different example. This comes from political science, where we might sample a number of households from 2 different states, New York and Texas, and we want to understand how household income predicts election preferences. Now in this case, we can still look at level 2 variables, such as who the governor of each state is and what political party they belong to. We can look at level 1 variables associated with the household, such as the religious beliefs of the individuals. And maybe what we're interested in is what this means about a household drawn from a random state. We're not necessarily just interested in New York and Texas. We might have sampled from New York and Texas for convenience. And we might be interested in using our model to make predictions about election preferences in general. But unlike in the case of Jenny and Johnny, we might actually be interested in New York and Texas. We're going to be studying New York and Texas again in the future, whereas it's very unlikely we're going to be studying Jenny and Johnny again in the future. So the random effects in this case might actually have substantive meaning. The residual variance associated with New York and Texas could be important to us. This is sometimes the case in other fields. It is often not the case in psychology. Takeaways from today's video are there are many examples of nested data. We talked about 3 examples today. We talked about students nested within schools, repeated observations of individuals, and we talked about households nested within states. Remember that variability that is specific to little units or level 1 units also leads to variability among big units. The household income, which varied among students, led to variability among average household income in schools, but the reverse is not true. Variability that's specific to big units does not lead to variability among little units. If a school is assigned a treatment or intervention, all of the level 1 units, the little units within that school, will also be assigned to that treatment condition. In psychology, random effects are typically incidental, but must be accounted for in our models. Think about Jenny and Johnny. We're not interested in residual correlations between daily observations for Jenny or for Johnny, but we need to understand that observations are going to be correlated for Jenny and observations are going to be correlated for Johnny when we're fitting our model. That way we can make predictions about a different random person in the future. In other fields, these random effects can be of actual substantive interest. We might be interested in the residual variability associated with New York and Texas, or we might not. It depends on our research question. This is worth knowing, but again, in psychology, typically random effects are something we need for methodological purposes rather than substantive purposes.